you have these two assets. You have Quai and you have Chi. Quai being the proof of work, I could say like a coin of the entire ecosystem. Chi being the flat coin that is effectively referencing cost of hash or energy. How do these then build out an EVM decentralized financial network?
Good question. So one thing that I'll make a statement of is that I don't think any system or economic design is meaningful if it can't scale. And I fundamentally think that is like what has held back crypto, is that you need to be decentralized, you need to be able to scale. And if you can't do that, whatever else you put on top of it is a proof of concept or an MVP. It's not something that can meaningfully grow and change things. This is actually point one. So we have this new architecture, this hierarchy of merchant mind chains, POEM obviously being a big component of how we do that. And so with this ability to go to 50,000 TPS in this sharded subnetted system, Quai is the EVM-compatible token. So it's account-based, it's deflationary because its emissions are proportional to the log of difficulty. Kind of has this baked-in price rise as the network grows, and that's your EVM-compatible system. So if you want to go risk on, you want to DeFi, like that's where you go about it. And then Chi is this energy dollar. So the idea here is if you just want to go risk off, you want to just price goods and services or contracts. Chi is a great mechanism for that because it can act as a unit of account. The other thing that Chi has, it is actually a UTXO ledger. It is fixed denomination. We enforce address non-reuse per block. And there's two other things that we do if we want to get into those, but the net out, it has cash-like privacy properties. So it's both a unit of account and it's a medium of exchange. So what we've actually built here is a parallel monetary system, which has a store value, a unit of account, and a medium of exchange all in one system.
Let's unpack that because it's actually kind of interesting. I'd love to hear your thesis on like decentralized finance, why it's important, why we need it. At the same time, you just said a bunch of things that I want to unpack real quick. One is you said it has cash-like privacy qualities. If I hand my neighbor $20, no one knows except for me and my neighbor unless I tell people. It would not be on public ledger. People couldn't go and see that transaction. There's some degree of privacy in that exchange. Are you saying that Chi, to some extent, has a privacy similar to that? Or is it still going to be like public on the ledger? How is it different from like USDC transferring?
It's going to be very much equivalent to you handing your neighbor a 20. 100%. Basically, when we look at these systems, you have a ledger, so you're still recording things on chain. And if we go back in time, originally people thought Bitcoin was private because it was pseudo-anonymous, meaning you had an account or an address, but it wasn't associated with your name, ergo we wouldn't be able to track it. One thing that gives that away are sats. The fact that you have 8 decimals of precision. When I spend money with you, how I do that and then get change reveals what I'm spending and what I'm getting change for. And then that associates all of my addresses and activities together, even if I'm using addresses well. So each one of those outputs becomes highly fingerprinted or unique. And this is actually how ordinals works in some ways. So Bitcoin, because of sats, is actually more like non-fungible tokens than it is like cash. And you can use that property to de-anonymize the whole chain. So the first thing you have to do is get rid of that fingerprint. And so you do that by creating fixed denominations. Now, if I have a fixed denomination system and I have address reuse, I still haven't gotten anywhere. So if you're always sending your change back to an address and you're reusing that address, everything is still getting reassociated. And if everybody's doing that, you're seeing the graph because people are reusing addresses and you can associate the uses in those addresses. That was the second statement, is that we enforce address non-reuse per block. The reason you can't do it over the whole chain is because it's like an MP hard problem. So you just do it per block. And then what that does is it makes every wallet, if they do the straightforward implementation path, they want to do good address use, meaning they don't want to reuse addresses. So then it makes the system all want to not do address reuse, which then means you've delinked the address problem. So now I've delinked the SAS problem and I've delinked the address problem. Now the only thing that you want to do is you want to make sure that people can't reaggregate. So there's this reaggregation problem in a fixed denomination system where I can break down an output. So I can have like 10 and I can make 10 ones. But if I were to take 10 ones and then put those back into a 10, I would again be linking all my addresses and any previous activity back together. So one of the other mechanisms is only the first transaction of Chi in a block can do a reaggregation. What that incentivizes is people figuring out, either to do it via a merchant or to do it cooperatively, because there's a limited amount of reaggregation ability in the system. What will end up happening is when you get change, you're going to pull all of your change out of your wallet and you're going to spend it at a merchant. And then that merchant is going to collect everybody's change for the day and they're going to reaggregate it in one transaction. What ends up happening is the entropy in this set of fixed denominations is always going up and not down. And then when it does go down, it's technically incentivized to happen in a cooperative way, which actually increases the total net entropy, not decreases.
Part of the issue initially was if I'm transferring an asset from person A to person B, it seemed like there was something you said that implied that the address of the sender would change or not be reused in a way that would make the sender identifiable. Now, does that happen automatically or is that just good wallet hygiene? So like effectively from the user standpoint.
So in a block, when we're processing a block, if you try to reuse an address, the transaction is invalid. If you want to implement a wallet, the simplest way for you to do it is have good address hygiene. So where it's not perfect, but we're making it so that your default like lowest energy path is to always have wallets with good address hygiene.
Okay, now when you say address hygiene, do you mean like I would send something to someone and then receive and spin up a new wallet for that? Like continuously have new wallets for new activities?
We actually use something called BIP47. It's a code. When we do a transaction, we share that with each other, which allows us to create a deterministic tree of one-time use addresses for our transactions. It's actually a known system. It's BIP47. If you look at Samurai, would use something like this. But basically, if you want to interact with the Qi ledger, because it's fixed denominations, you basically potentially need to always have multiple outputs, and you're not allowed to reuse outputs. So I can't just give you like one address and be like, oh, send me a bunch of things with that one address. Like it won't work. To functionally use the system, I have to use BIP47. We'll exchange these codes. You'll be able to derive however many output points you need for a given transaction based off what you have without having to have this like back and forth discussion with me in terms of the derivation.
Is that abstracted away from the user? If user A sends money to user B, they don't have to spin up 15 different wallets and play with all these different IPs. Right?
That's right. That's the thing, but with like accounts versus UTXOs is UTXOs have wallets. So the wallets are technically already doing this with Bitcoin. They're doing it in a different way, but they're already technically doing it. So if you actually opened up your Bitcoin wallet, you would have this big list of UTXOs. And your wallet, every time you're like deciding to send something, is figuring out how to do it based off the UTXOs you have. So you already have a set of many addresses with many things.
So any one given wallet may have a bunch of different addresses for a single seed phrase.
You basically have one wallet address code, you share that with somebody, and then the software figures out how to generate enough and transmit it correctly and then respend it correctly and all of those things. So you still just see like an aggregate balance, and then behind the scenes, it's doing the work.
And now, is that different from traditional EVMs like Ethereum? They also have a bunch of different addresses per account. Or is it the same? What is the thing that makes this more robust?
In Ethereum, in an account-based system, basically all the transactions you've ever done are on that account. If you sent me money, I could then go to Etherscan and track back everything that you've ever done with that account since the beginning of time. So with UTXOs, if you sent me something, depending on how you manage your addresses in UTXOs, I could do that. It might be a little bit harder. But then if you sent me fixed denominations, you didn't reuse addresses, it would become impossible at some point for me to track what you're doing. So that's like how Qi works. From a user's perspective, a wallet in Qi looks much like an account in Quai or the EVM. So you just have one identifier that identifies that money. So from a user's perspective, they look analogous, but under the hood, they're doing a lot different types of work.